few questions which were asked in previous GPATs. So let us start with the first one. This is a match list A with list 2, list 1 with list 2. It is related to the dissolution test apparatus, which are given in the United States Pharmacopoeia. Currently, we will not discuss any of the answers. At the end of the session, it is open for you to search for the answers from the lecture only, if it is possible. Okay, so these are the sample questions which were asked. Second question is, the picking is a term which is used to describe the separation of tablet in two layers, or a situation when surface the material from tablet is sticking or being removed, or unequal distribution of color, or the parietal or complete separation of top or bottom crown. In 2022, in the process of sugar coating to prevent moisture penetration, which of the following step is performed? Seal coating, subcoating, shear coating, or polishing. In 2022, there are two statements are given. During the process of decompression in tablet manufacturing, expansion occurs in some tablets. And the reason given is expansion occurs in some tablets because of plastic deformation that has occurred during compression process. And there are four options. A and R are true, and correct explanation or not correct explanation, etc. In 2022, two more questions were asked from the tablets only. In the process of adding lubricant to a granulation, the lubricant is divided finely by passing through 60 to 100 mesh nylon cloth. The process is known as bolting, mixing, tumbling, grinding, etc. Which of the following manufacturing process may not be required for oral solid dosage forms? Material handling, blending, chemical weighing, and aseptic filling. In 2022, this is a question. An excipient Ludipress is used for the liquid dosage form, and it is composed of, actually it is used for solid dosage form as well, and that's why I have included over here. It contains dextrose monohydrate plus collidone, lactose plus collidone, lactose plus collidone plus collidone 30 plus collidone Cl, and dextrose plus collidone 30 plus collidone Cl. These are four options. In 2019, that in tablet HPMC is used as. Now, this question you need to actually remember particularly because of the reason that this question was challenged during the GPAT. Only one option was to be selected over here, but there are two correct answers over there. And at the end, we will discuss that also, if time permits. Then microcrystalline cellulose, MCC, is also known as. These are four options available. One of them is the brand name of the MCC. So these are few sample questions you need to take in your mind, keep in your mind while going through this lecture, so that it will strike when the answer is there. And that's why I'm not sharing the answers at present. So let us start with the formulation of tablets. The formulation of tablets, that is, anyway, the formulation means formula, which ingredients are present. So whenever we are formulating a tablet, we are preparing a tablet, we need to incorporate some ingredients. And this is the list of the essential parts or essential ingredients which are to be incorporated in a tablet. First one is the API, diluent, binder, disintegrant, gradient, lubricant or anti-adherent, and miscellaneous agents. Actually, gradient, lubricant, and anti-adherents are different, but normally they are discussed together because there is a very thin boundary between their actions. And majority of the agents which are used as gradient can also be used as lubricant and anti-adherent, and vice versa. And that's why we are discussing them. We are keeping them or classifying them together. So let us start with the API. API is the active pharmaceutical ingredient. We are not using the word tablet, drug. We are using the word API because there are a number of ingredient or number of active agents which we are incorporating. They are not drugs, but they are nutritional supplements. For an example, vitamins or amino acids. And that's why we call them API, active pharmaceutical ingredients. All tablets except placebo, they contain API. All tablets except placebo. Placebo is used for minimizing the psychological effects. That is, sometimes the person is suffering from any psychological disorder, or during clinical trials, to create a psychological effect only, we are giving placebo. So they are plain tablets containing all the ingredients except the active ingredient. Next is diluents. Diluents are actually the heart of tablets. There are two purposes of incorporating diluents in a tablet. First one is to increase the bulk. Sometimes the dose of your API is very less. For an example, for salbutamol, it is 4 milligram. For number of anti-hypertensive drugs, it is in the range of 10 to 50 milligrams. Okay. But when the dose is very low, it is not practically possible to prepare a tablet. And if the tablet is prepared, then also it will not be easy to handle by the patient. And that's why to increase the bulk, we are incorporating diluent. Sometimes the dose is sufficiently high. For an example, in case of all the cephalosporin antibiotics, you might have seen the tablets of Cefixime, 200 milligram. The weight of the Cefixime 200 milligram tablet is approximately 550 or 650 milligrams. The active ingredient is only 200 milligrams. The reason is many of the API are having poor compressibility, and they cannot be compressed into the tablet if we are not incorporating the diluents. So another purpose of incorporating a diluent is to increase the compressibility. Most commonly used diluents are lactose, microcrystalline cellulose, dibasic calcium phosphate, modified starch, fructose, etc. First and foremost is the lactose. It is the oldest diluent which is used in the tablet manufacturing. It's a milk sugar. It is obtained from milk. The lactose is mainly available in different forms like alpha form and beta form. Currently, spray-dried lactose is more commonly used. Now, the spray-dried lactose is prepared by spray drying. And when we spray something, it is in the form of droplet. And that is why we know that droplets are always spherical in shape. So, the spray-dried lactose will have spherical shape. Another thing is, during spray drying, the solvent from the core will evaporate, and that will lead to the leaving behind the pores, which makes it porous. And because of that, two ideal characteristics which are required for compression are imparted in a spray-dried lactose. One, that is the sphericity, which will impart good flow. And second is the compressibility. Because of the porosity, it is having good compressibility. So spray-dried lactose is having both advantages: good sphericity, that is good flow property, and good compressibility. It is water soluble, it is directly compressible, and it is hygroscopic in nature. Now, that is the problem with the lactose. As it is hygroscopic, it can absorb moisture from the surrounding environment. And because of that, those API which are sensitive to moisture, they are normally not compressed with the lactose. Lactose is available under different brand names like Spherolac, Flolac, Fast Flow, Super Tab, etc., etc. And it is incompatible with the drugs which contain primary and secondary amines. The reason behind that is the Maillard reaction. In one of the previous GPAT, this question was asked. I'm not though listed in the list, but it was asked. Maillard reaction. Actually, Maillard reaction is the delayed kind of incompatibility reaction in which the color of tablet changes due to the reaction between lactose and the primary or secondary amine containing drugs. And the color becomes brownish. So that reaction is called Maillard reaction. It is a delayed kind of reaction. And that's why it cannot be compressed with the primary or secondary amine containing drugs. So in your GPAT, it can be asked that the examples of drugs are given. For an example, isoniazid or rifampicin or something. So you need to isolate which drugs contain primary or secondary amine. So in that case, you need to use knowledge of two subjects, your pharmaceutics as well as your medicinal chemistry. Next is microcrystalline cellulose. Now, microcrystalline cellulose is a semi-synthetic derivative of cellulose. And it is hygroscopic, hydrophilic, and water insoluble. Lactose is water soluble, hygroscopic, and hydrophilic, while microcrystalline cellulose is water insoluble, still hygroscopic and hydrophilic. It can absorb the moisture, it can attract the moisture, and it lost the moisture or water. It is directly compressible, it is having good flowability and good compressibility. Microcrystalline cellulose can also act as diluent because when it absorbs the moisture, it swells. And because of that swelling action, it can also facilitate the disintegration of tablets. It is available under the brand names like Avicel, Celfia, Pharmacell, and Tabulose. Microcrystalline cellulose is incompatible with strong oxidizing agent because it is cellulose. Normally, cellulose is found in the wood. Okay, and in presence of strong oxidizing agent, there are chances of the oxidation It can even catch fire if very strong oxidizing agents are present. And that's why it is incompatible. This is the list of different grades of microcrystalline cellulose with their brand names. Most common brand name is Avicel, and Avicel PH. PH grade refers to pharmacy grades. And the suffix 101, 102, 103 are based on two parameters, moisture content and the particle size. So 101 is having nominal particle size of 50 microns and moisture content less than 1%. Avicel pH 102 is having the particle size of 100 microns. That is the larger grade. Now, when we are going for direct compression, we prefer the larger size diluents, because as the size decreases, the flow deteriorates. As the size increases, the flow gets improved. And hence, we use the larger granule size of the Avicel to achieve good flow. So when we are going for direct compression, we prefer Avicel pH 102. When we are going for granulation, we prefer Avicel pH 101. Okay. Similarly, when your API is moisture sensitive, we will prefer Avicel pH 103 because it is having the moisture content less than 3%. And so on. So these are the list. Next is calcium phosphate dibasic. Calcium phosphate dibasic is water insoluble and non-hygroscopic. Water insoluble and non-hygroscopic. Now, calcium phosphate dibasic is having a problem that it is actually abrasive in nature. And when we use dibasic calcium phosphate with less amount of lubricants, then it may lead to wearing and tearing of the dies and punches. There are chances of generation of scratches on the dies and punches surface. And hence, the tablet formulation should be properly lubricated when we are using dibasic calcium phosphate as a diluent. It is incompatible with the alkali sensitive drugs and tetracyclines. You might have studied while studying the tetracyclines that they cannot be incorporated with the milk because they form a complex, and that prevents the absorption of the tetracyclines. So, dibasic calcium phosphate is also containing calcium. It cannot be formulated with the alkali sensitive drugs and tetracyclines. The brand names of the dibasic calcium phosphate are ATAB, Dicafos, M-compress, Anhydrous, Fujicalin, etc. etc. Mannitol. So mannitol is actually D-mannitol. It's a sugar. It is hexahydric alcohol, which is related to mannitose, and it is isomeric with the sorbitol. Mannitol is a white, odorless crystalline powder, and it has a sweet taste, approximately as sweet as glucose. Microscopically, it is needles, and it shows polymorphism. It is available under the brand name like Improve or Perlitol. Now, the advantage with the mannitol is it is having negative heat of dissolution. Where it dissolves, it absorbs the heat. And that is why it is the diluent of choice when we are preparing mouth-dissolving or chewable tablets. Because mouth-dissolving tablets or chewable tablets are dissolving in the oral cavity. And it will improve the feel. When it dissolves, it absorbs the heat. And that's why it is preferred over there. It is not showing Maillard reaction. So that is also an advantage. These are different grades and brand names of the mannitol. Most common brand name is Perlitol, and it does not undergo Maillard reaction. In one of the GPAT, it was also asked that which of the following diluent will not undergo Maillard reaction. So answer over there for the sugars is the mannitol. Then next category of the ingredients is binders and adhesives. Binders are incorporated in tablet to increase the binding, increase the holding of the granules together. Now, the binders can be incorporated in three different ways. Dry binder before dry granulation, dry binder before wet granulation, and solution binder. When we are going for dry granulation or direct compression, we can mix all the ingredients, including the binder, and we go for compression, whether for direct compression or dry granulation. Dry binder before wet granulation. When we are preparing wet granulation, tablets by wet granulation, at that time also, we mix the binder in the dry form, and then we sprinkle the granulating agent to activate that binder and to carry out the granulation. And last is solution binder. That is, we dissolve the binder in a granulating agent solution. A granulating agent, we make a solution and we use that solution as a granulating agent. Out of all these three, the last one, that is solution binder, is the best one because it provides the best results. we can easily check the uniformity of distribution of the binder, because as it is present in the solution, we can check that the entire mass has been wet or not, and that is why it is giving better results. Another advantage with this is solvent migration. When we are drying the granules, the binder along with the solvent will move to the surface. It will migrate to the surface, and during this migration, the surface of the granules become rich with the binder. Now, both the binder rich surfaces of two granules, when they come in contact with each other, they form better bonds. As we know, in tablets, the bonding takes place by dry binding and not wet binding. The granules which we are drying, they contain 2 to 4% of the moisture only. And that is why the actual bonding which takes place is between dry forms and not between the wet forms. So, as if the surface is binder rich, it will give better quality tablets or tablets with good hardness, good crushing strength. And that is why it is helpful. The commonly used binders are starch paste, acacia, hydroxypropyl methyl cellulose, polyvinyl pyrrolidone, and gelatin. They can be used as a binder. Now, here you need to remember PVP. PVP is used as a binder. Cross-linked povidone or cross-linked PVP is used as a disintegrating agent. PVP is available under different brand names like Colidone. Okay, Colidone 30, PVP K30 or PVP 30 or Colidone 30. That is the brand name of polyvinyl pyrrolidone. Similar is the for starch. Starch in dry form can be used as a disintegrant. In the paste form, it can be used as a binder. Next is the disintegrants. When we prepare tablets and when the tablets are ingested, to facilitate the absorption of API, it is required to disintegrate the tablets. So, the tablet should first break. When the tablet is intact, the dissolution only takes place from the surface. When it disintegrates, it is now separated in the form of granules. The next step is the deaggregation. That is the breaking of the granules into small particles. Okay. As the tablet disintegrates from the intact tablet, the surface area increases. And as the surface area increases, rate of dissolution increases. When it deaggregates, further surface area increases and further the dissolution rate increases. So, for better dissolution and better absorption, it is required to disintegrate and deaggregate the tablet. Now, there are some disintegrants which lose their activity when they are wetted. That is, when they come in contact with the water. And hence, they are to be incorporated in two portions. One that is intragranular and second that is extragranular. That is, one during preparing granules and second after preparing the granules. One of the example of such disintegrant is starch. Nearly all others can be incorporated only intragranularly. That is not an issue. But still, for safety purpose, we incorporate the disintegrants in two different portions. One while preparing the granules and second after preparing the granules. There are mainly four mechanisms of disintegration: wicking, swelling, gas generation, and enzyme action. First one is the wicking. Wicking, that is wick. The water is pulled by capillary action. The same mechanism which takes place in a lamp, oil lamp. Due to wicking, due to capillary action, the oil is pulled to the top of the wick and it burns. It provides the light. The same mechanism takes place over here. So, the disintegrants are distributed throughout the tablet mass. They will pull water. They will distribute the water throughout the tablet and they will break the bonds because of the wetting, and thereby they will help in disintegrating the tablets. The disintegrant that act by wicking mechanism are starch and cross-povidone. Cross-povidone is falling under the category of super disintegrants. It is the disintegrant which provides faster disintegration at lower concentration. Starch is used in the concentration range of 5 to 10%, while cross-povidone is used in the concentration range of 2 to 5%. It is available under different brand names like Colidone CL, Colidone CL-M, and Polyplasdone XL. These are the brand names. Next mechanism is swelling. When the disintegrant absorbs the water, it swells. It increases its bulk, and thereby the strain, the force will be created from within the tablet. It will lead to breaking of the tablet. there are a number of materials which swell nearly 200 times their original volume when they absorb water. You might have heard about the magic balls, which we are using for decoration purpose. They are originally the size of a grain. When we keep it in water, they swell and they become like marble. Okay, so that is they're increasing their volume nearly 200 times. The same is possible with number of super disintegrants. Commonly used swelling super disintegrants are sodium starch glycolate, that is also known as carboxymethyl starch, which is available under the brand names like Explosol, Explotab, Glycolis, Primogel, and it is used in the concentration range of 2 to 8%. Next is cross-carbamylose sodium, also known as cross-linked carboxymethyl cellulose, cross-linked CMC. It is available under the brand names like Ec-Diasol, accelerated dissolution, Ec-Diasol, Explosol, Primulose, Solutab, Vivasol, etc. And it is used in the concentration range of 0.5 to 5%. Now, if we use cross-linked sodium CMC at a very high concentration, it may lead to gelling and it may delay the disintegration time. So normally, it is used in the concentration range of 0.5 to 5%. Next is LHPC, low substituted hydroxypropyl cellulose. It's a cellulose derivative, and that can also act as a disintegrant, super disintegrant. Next mechanism is the gas generation. There are some agents like sodium bicarbonate or calcium carbonate. They generate gas when they react with the acids. So this mechanism can be used for the disintegration of normally effervescent tablets or soluble tablets. Soluble aspirin tablets are available in the market, which are manufactured with calcium carbonate. So when they come in contact with the hydrochloric acid or stomach fluid, the calcium carbonate will react with the hydrochloric acid and carbon dioxide gas is generated, which leads to disintegration of the tablet. Next is enzyme action. Some binders like gelatin, they are insoluble in stomach and small intestine, but they are digested by the microorganisms which are present in the colon. And that's why they can be used as a tablet binder for the tablets which are manufactured for colon targeting. Another example of such kind is the guar gum. That is also insoluble throughout the GIT. It is digested by the colonic microflora. Next category is the glidants. The purpose of glidants is to improve the flow from the hopper to the dye cavity. When they are preparing tablets, if the flow of the granules is not proper, then the dye cavity will not be filled properly every time, and hence your tablets may fail in the disintegration test. In the weight uniformity test, by mistake. So the flow should be proper, and to improve the flow, we are using glidants. So what glidants do is they reduce the friction between two particles of the granules. As we know that we have prepared the granules, they are irregularly sized. Though they are nearly spherical, but still there are irregularities. And because of that irregularities, there are chances of locking. So the glidants will coat this surface and make them smooth, so that there is minimum friction between two granules and they flow properly. Commonly used glidants are magnesium stearate, zinc stearate, stearic acid, and colloidal silica. You need to remember all these glidants are hydrophobic in nature. Same is the case with lubricants, and that's why their use should be as low as possible. If we can attain good flow with 0.5% of the glidant, we should not go for 1%. Their use should be minimum. Next is the lubricants or lubricating agents. They minimize the friction between the tablet surface and the dye cavity. So during ejection, sometimes what happens that your tablet sticks to the punch, to the inner wall of the dye. If the friction is high, then there are chances of generation of the rings or scratches on the dye wall, or sometimes the breaking of the tablet. So to facilitate ejection, the friction between the dye cavity and the tablet surface should be minimized. So to minimize that, we are using lubricants. Commonly used lubricants are talc in the concentration range of 1 to 10%, magnesium stearate, stearic acid, hydrogenated vegetable oil, zinc stearate, calcium stearate, and SLS. Mind well, out of all of them, only SLS is water soluble. Rest all are water insoluble. So they impart hydrophobicity to the tablet. If we incorporate more amount of lubricants or glidants, then the tablet surface becomes hydrophobic, and that is why it may show delayed disintegration. So your tablet may fail in the disintegration test. When we are preparing soluble tablets, then we prefer use of SLS as a lubricant, because all this the lubricating agents and glidants are water insoluble. So we need to use water soluble in disintegrants and diluents only, and that is the SLS. Next is anti-adherents. They prevent the material from sticking to the punches and the dies. The problems which arise due to improper drying or sticking with the die cavity or the upper or lower punch, that is picking. And to avoid that, we need to use anti-adherents, which will prevent the adhesion. Commonly used anti-adherents are the colloidal silica. That colloidal silica is available in the different brand names like Cabosil, Aerosil, and it is used in the normal concentration range of 0.1 to 1%. It is nothing but silicon dioxide in the colloidal range. Microcrystalline and cellulose, MCC, can also be used as an anti-adherent in the concentration range of 5 to 20%. The mechanism over here is something different. The MCC is good adsorbent, and that is why it can absorb the liquids which are present in the tablet. If we are incorporating any liquid in a tablet, then there are chances of picking and sticking. To avoid that, we use MCC as an adsorbent, and that will also facilitate the anti-adherent activity, that is, prevent the sticking. Next is miscellaneous ingredients. There are some ingredients which are to be incorporated in tablets as and when they are required. Okay. The examples are colorants, flavoring agents, and anti-capping agents. Colorants are normally incorporated to avoid mottling. Mottling is uneven distribution of the color. When we observe mottling, we should incorporate some colors to hide the mottling. It is sometimes unavoidable. When your API itself is having color, we cannot avoid it. And that's why we should make the entire tablet the same color, that of the API, so that we can avoid the mottling. Next is the flavoring agents. Flavoring agents are normally incorporated in the orodispersible tablets, and anti-capping agents, they are used when there are chances of capping. Capping is the removal of upper or lower crown of the tablet. Normally, we are using sucrose as anti-capping agent because it acts as a binder, and that's why it holds the entire tablet together. It will prevent the capping. Now, there are some co-processed excipients. One of the questions was asked in GPAT. We already listed that, Ludipress. So, co-processed excipients are the excipients which are processed together. That is, two or more excipients are processed together to yield a single ingredient or single excipient. And that can act as all-in-one. That is, it can act as a diluent, as a disintegrant, as a binder. And we only need to incorporate the API and lubricate it, compress it. So we need not to incorporate glidant, we need to incorporate binder and disintegrant. We can use it for a direct compression purpose. And that is the advantage. One of the example is Ludipress. It is the mixture of lactose, Collidone 30 and Collidone CL. Selectose, it is a mixture of lactose and cellulose. Dipac, sucrose and dextrin. Crosol, MCC and silicon dioxide. Avicel CE15, Guargamen, MCC, it is used for colon targeting. Okay, and so on. So these are some examples of co-processed excipients. Those excipients which are processed together. Now, we have completed all kinds of excipients. One more term sometimes you will come across is the polyfunctional ingredients. Polyfunctional ingredients are those ingredients which are having more than one function. For an example, starch. It can be used as a binder. It can be used as a disintegrant. In dry form, it is disintegrant. In a paste form, it is binder. Similarly, talc. It can be used as a glidant. It can be used as a lubricant. Magnesium stearate. It can be used as a glidant, as a lubricant. Okay. So you need to remember those ingredients which are having more than one function, or polyfunctional ingredients. Similarly, you need to remember the povidone. Cross-linked povidone or cross PVP is used as a disintegrant. Povidone or PVP is used as a binder. So sometimes that kind of questions can be asked. Yeah, one more thing in the formulation part, that you you cannot incorporate, or the disintegrants are not required in chewable tablets. If you look at the types of the tablets, you have already studied, I think. So the chewable tablets, they do not contain the disintegrants because they are not meant to disintegrate. Now, manufacturing of the tablets can be manufactured by different techniques: dry granulation, wet granulation, steam activated granulation, and melt granulation. These are the granulation techniques, and they can also be prepared by direct compression. So which technique is to be used, that depends on the attributes of the API. So this is a flow sheet which will help you decide that which method should be used. So if your API is having good flow and good compressibility, if the answer to both this question is yes, you can go for direct compression. If any of the question is not yes, you need to think of that. If only flow is poor, you need to ask, can it be improved by glidants? If yes, we can go for direct compression. If only compressibility is poor, if it can be improved by using diluents, good. Yes, we can go for direct compression. If no, we cannot, then we must go for the granulation. Now, which granulation is to be used? That depends on the characteristics of your API. If your API is moisture sensitive, yes, we cannot go for wet granulation, and hence we need to go for dry granulation. If your API is not moisture sensitive, we can go for wet granulation. So this flow sheet will help you decide which method of manufacturing should be used. Now, as far as industries are concerned, they are interested in the direct compression because it is the method which is the cheapest one in preparing the tablets, and that's why it is used most commonly by the industries for preparing the tablets. But the API which we are using are not having the attributes which suit that manufacturing, and hence the alternative remaining with the industries is the granulation only. So at present, currently also, nearly more than 70% tablets are manufactured by wet granulation. Only less than 10 to 20% tablets are manufactured by direct compression, and rest by other methods. Okay, this is the schematic of manufacturing process. In this, there are different drawings. The green line shows the steps which are used for dry granulation, the purple line for wet granulation, the blue line for the direct compression, and orange line for common steps of the manufacturing. Okay, so that are shown by this flow sheet. So first thing is we need to blend the API with the excipient. It is required for all. And co-milling. Co-milling is option. Co-milling is reducing the size. Nowadays, all the excipients are available with their grades. And as I said, as we have already seen, that MCC available in the brand name of Avicel, it is available under different grades. So we can use that particular grade directly. We need not to go for grinding. Same is with the API as well. All the ingredients are available in different grades. And so manufacturer can directly procure that grade. They need not to go for grinding. So this step is optional. Then is blending, that is mixing. After mixing, if we go for dry granulation, we go for roller compaction or dry granulation, milling, and then compression. If we go for wet granulation, drying, and milling and compression. If we go for direct compression, the blend is directly compressed to prepare a tablet. So these are the steps which are required. Direct compression is the fastest and the cheapest process, and the most preferable for high-speed manufacturing and continuous processing. Okay. In March last year, that is March 2023, US FDA has approved the final guidelines for the continuous manufacturing, that is ICH Q13 guidelines. You might have heard about, I think, ICH Q13. ICH is the International Committee on the Harmonization. Previously, it was International Conference on the Harmonization. Now it is International Committee on the Harmonization. And ICH Q13 guidelines are approved by US FDA in March 2023. So now they are focusing on the continuous manufacturing. So if you want to manufacture the tablets continuously, the direct compression is the only technique which we can prefer, because we only need to mix all the ingredients and compress it. The steps involved are sizing, it's optional, mixing and compression. If we cannot go for the direct compression, we need to go for granulation. So from granulation, there are two techniques, dry granulation and wet granulation. Under dry granulation, there are two steps, slugging and roller compaction. Slugging, that is the tablets of larger size, they are called slug. So initially the slugs are prepared and then they are broken. This is the slug. Okay. The large tablet that is broken, they are sized and they're lubricated and compressed. Now the question is, when we can prepare large tablet, why can't we prepare the tablet of the actual size? The answer to this question is, the slugs are prepared, but they are not required to be uniform with respect to their size, their weight, and the drug content. While your actual tablets are required to be uniform with respect to their size, their weight, and their drug content. So, to impart that qualities, we need to prepare granules. The granules are only prepared when your API is not having good flow or good compressibility. So, to enhance compressibility and flow, we need to prepare granules. Slugs are not required to be containing that attributes, the good crushing strength and uniformity. So, they are broken, they are prepared, the granules are prepared and they are further compressed to prepare the tablets having uniform size, uniform weight, and uniform crushing strength. Next is roller compaction. This technique is also known as Chilsonator. Here, as the name says, the mass is compacted between the rollers. Here are the two rollers which are rotating in opposite direction. So when the mass come in contact with them, between them, it is compacted and a ribbon is formed. This ribbon is then broken down by the mill, that is hammer mill normally. So this is the primary milling, and then it goes to secondary milling over here. So over here, the granules are prepared. There is the granulator. This is the screen. This will only allow the passage of particular size of the granules. If the granules can pass through this, they can pass. If they are bigger, then they are rotating again and their size gets reduced. Here, there are three inclined sieves. Okay, two inclined sieves. The upper sieve is having the size of the upper limit of the granules. Say, you want to prepare the granules of 20-40 mesh. Okay, so they should pass through 20 mesh sieve and they should retain on 40 mesh sieve. So the upper screen is 20 mesh and the lower screen is 40 mesh. So granules which are oversized will roll from the 20 mesh sieve and they are recycled. The granules which are of actual size, that is less than 20 mesh and above 40 mesh, they will roll to the product collection bin. And the granules which are smaller than 40 mesh will be collected as fines. We require some fines. While preparing the tablets, nearly 10 to 15% of the fines are incorporated in the actual size granules to impart good compression properties. Okay, nearly 10 to 15% of the fines are incorporated in actual size granules, and that is why we require these fines to be incorporated. Next is the wet granulation. It is most commonly used technique, wet granulation. Here, the mass is prepared by wetting. So the steps are weighing and blending, preparing the damp mass, screening of the damp mass, drying, sizing, adding lubricant, and formulation of the tablet. This is an equipment which is used for granulation, that is called RMG, or rapid mixer granulator. It is having two blades. The central blade is known as the rotor blade and the central blade is known as the rotor blade, and this is a chopper blade. This rotor blade will throw the mass away from the center, and the chopper blade will chop it, will break the lumps into the small parts. And this is the granulating agent spray. So when the granulating agent is sprayed, the mass becomes damp. The rotor blade will throw it away. as the geometry of the equipment is like reverse cone, the mass will rise to the upside, but as it is reverse conical, it will fall due to its gravitational force again on the rotor blade. The rotor blade will throw it again to the wall and the chopper blade will break. Now, the end point of the granulation was previously assessed by the energy consumption. If you go on adding liquid to a dry mass, initially it becomes hard for the equipment to mix it. Once the quantity of liquid increases beyond a certain limit, it becomes easier. So we need to prepare a damp mass. So it should not be slurry, it should not be dry mass. So the maximum energy is consumed when the mass is damp, and that is considered as an end point of the granulation process. Now at present, we are having NIR probes, near infrared probes, which are continuously monitoring the moisture content in the granulation or water content in the granulation. Once sufficient water content has been attained, then we will stop the granulation process. And there is no need to use any secondary measures. This is the flow sheet of the tablet manufacturing process. Now, all-in-one granulation method. This is most commonly employed currently in the industries. The most commonly used all-in-one process is the fluidized bed granulation or fluidized bed systems. Okay. Here, this is a fluidized bed granulator. It can be used for mixing, drying, and granulation, as well as for coating. So it serves four purposes in a tablet manufacturing process: mixing, drying, granulation, and coating. And hence, sometimes it is referred to as fluidized bed systems or FBS. Okay, it is following all the it is used for all these four purposes, and that's why it is considered as called as fluidized bed systems. As the name says, here the granules are fluidized. The powder is initially fluidized, and then the granulating agent is sprayed. Now, during fluidization, we require the dry air with normal temperature. During drying, we require dry air, but it should be hot. And the flow rate should be high because the powder is easy to fluidize as compared to the granules. The size of powder is smaller, size of granules is higher. So we need to continuously change the temperature and flow rate of the air in a fluidized bed systems for proper granulation. This is an animation which shows the continuous fluid bed granulator. As you can observe over here, there are four tunnels over here. Okay, four chambers over here. And these chambers are having different flow rate. Okay, all these four channels, channel 1, 2, 3, and 4 are four tunnels. They are having different flow rate. At the same time, there are three different spray guns at the top. These spray guns are having different rate of spray and different composition. And we go for mixing, granulation, and drying. All takes place in a single chamber. And the mass is continuously entering, my mistake. The mass is continuously entering from the inlet and it is continuously discharged from the outlet. Okay. So that is continuous fluidized bed granulator, and it is the need of today because industries are switching towards the continuous manufacturing. Now, moving to the tablet press. Tablet press is the tablet compression machine. Nowadays, most commonly we are using rotary tablet machines, but mainly there are two types of tablet machines: single punch tablet machine and rotary tablet machine. Under rotary tablet machines also, there are two types of tablet machines: single rotary or simple rotary tablet machine and double rotary tablet machine. Single punch tablet machines are nowadays normally not used. So the important part of the tablet machines are punches and dies. There is always a set of punches and dies: upper punch, lower punch, and a die. Mainly there are two types of tooling possible: B tooling and D tooling. Tooling are decided on the basis of the size, the diameter of the punches. Okay. For small scale manufacturing or lab scale manufacturing, we prefer B tooling. For industrial scale manufacturing, we prefer D tooling. The diameter of D tooling is larger than that of the B tooling. Okay. These are the measures of the B tooling and D tooling. Okay, the head diameter or the barrel diameter of B tooling is 19 mm. The barrel diameter of D tooling is 25.35 mm. The length is similar. That's not a difference in the length. The die cavity or die size is 1.5 inch in the D tooling and 1.18 or 0.94 in B tooling. In case of B tooling, there are two types of dies possible, B type and BB type. While in D tooling only there is one type of die, that is D type. Okay, this is required because we need to hold these punches and dies in a tablet machine, in a turret or die table. Now, whatever size of tablet you want to prepare, mind well, whatever size of tablet you want to prepare, the dimensions of barrel and the punch head remain constant. Only changes take place at the tip. These are called punch tips. And the dimensions of punch tips will decide, and the die cavity, the inner part of the die, not the outer diameter, but the inner diameter of the die will decide the size of the tablets. Okay. If you look at the punches, you can notice that the punch tip length of upper punch is smaller than that of the lower punch. So if two punches are kept on a table, you can easily recognize which one is the upper punch and which one is the lower punch. Lower punch tip length will be more than that of the upper punch. The reason being, the lower punch always remains in a die cavity, while upper punch only enters the die cavity during compression. There is no any other function of the upper punch, while the lower punch is having three functions: weight adjustment, compression, and ejection. And that's why it is always remaining in the die cavity itself. Single punch tablet machine. This is a machine. I'm not going to discuss it. This is a animation which shows how the tablets are manufactured on a single punch tablet machine. Rotary tablet press. This is a rotary tablet press. You might have seen at your college as well. That's why there's no need to show it again. And let me show this animation. This shows all the processes taking place during compression. Now, this is the pre-compression roller and this is the main compression roller. During compression, sometimes air is entrapped into granules. When the granules are filled, they are filled volumetrically. We cannot avoid the presence of air. So when the air is entrapped and when the tablets are compressed, then the air is also getting compressed. When we remove the pressure, then the air will try to expand. It will try to regain its original size and shape. So it will push the layers apart, and that's why it may lead to the breaking of the tablets. That leads to lamination and capping. So to avoid that, we are going for pre-compression. So pre-compression roller is a smaller roller which imparts lesser pressure, but it will expel the air. So the air which is present will be expelled, and then we go for main compression. This is the main, this is the weight adjustment knob. Okay, weight control unit. We can adjust the height of this ramp. This is the punch track which will guide the punch. It is called track. If you look at the animation, the upper punch only remains in the die cavity during compression, while the lower punch helps in the weight adjustment in this place, compression between this, and ejection over here. So it has three functions to perform in a rotary tablet machine. Upper punch has only one function. Lower punch has three functions to be performed in the rotary tablet machine. This is a double rotary tablet machine. Now, if you look at the double rotary tablet machine and rotary tablet machine, the rotary tablet machines are having the number of punches in even 10 stations, 16 stations, 24 stations, etc. While double rotary tablet machines will always have odd number of punches, 27, 33, 37, 41 or 49. There are two die cavities and two compression rollers. If you look over here, this is one compression roller and this is second compression roller. This is one hopper and this is second hopper. This is one feed frame and this is second feed frame. So two tablets are prepared during each cycle, each rotation. So if there is 27 station rotary, double rotary tablet machine, 54 tablets are prepared on one rotation. Okay. So they are having always odd number of punches. The reason being, the compression should take place alternatively. Two compression rollers are there, and there should not be two punches under compression at a time. આવું ના થવું જોઈએ, આમ ચાલવું જોઈએ. બરોબર? એક compression થયું, બીજું થયું, and that's why they are always following this pattern, and hence the number of punches are odd. If the number of punches are even, two punches will come under the compression roller at a time. So movement will be like this. It should not be like this. It should be like this. To manage the machine to decrease the load on the die table, and hence it is having odd number of punches. Now, moving to the last part, that is problems and remedies. When we prepare the tablets, there are some problems which are arising, like picking, sticking, capping, lamination, mottling, weight variation, friability, double impression, chipping, cracking, etc., etc. Let us discuss each of them in detail. So these are the problems which we are going to discuss. Capping and lamination. As it is shown over here, the first tablet is the simple tablet. That is normal tablet. This is the tablet with capping. The cap is removed. That is, upper part or lower part of the tablet is removed. That is called capping. And this is lamination. The tablet is separated in two or more layers. This is capping. Only upper or lower crown is removed. Okay. So this is the problem, capping or lamination. Now, what are the reasons and remedies for that? So the reasons for capping and lamination are, first is the air entrapment. As we have discussed, when air is entrapped, the air will try to regain its original volume. It will force the layers apart, and it will lead to the capping and lamination. So to prevent air entrapment, we need to go for pre-compression. Second is the deformational properties, plastic deformation and elastic. When plastic deformation is more than elastic recovery, then we need to slow the speed of machine. We need to increase the dwell time. Okay. Dwell time is the time for which the upper punch remains in the die cavity. Dwell time is the time for which the upper punch remains in the die cavity. So, if the upper punch remains for a longer time into the die cavity, it will lead to proper deformation. And that's why the material will not try to regain its original size shape. So, they will not lead to capping and lamination. So, we can slow the speed or we can reduce the final compression pressure. When we are using deep concave punches, then there are chances of capping. As we are using deep concave punches, some of the tablet mass remain within the die cavity or below the die table during ejection. Now, when the scraper forces the tablet to eject, the mass which is remaining inside the die cavity will experience the objection or the restriction from the wall, and it may lead to capping. So the lower cap sometimes may be removed. Separate થઈ જશે. That is called capping. So when it is not required to use the deep concave punches, we need to use flat face punches only. Next is over-dried granulation. If the granules are over-dried, there won't be proper binding between the material. As we have discussed, we need to maintain at least 2 to 4% of the moisture in the granules. More than 4% will lead to picking and sticking. Less than 2% will lead to capping and lamination. It will not provide proper binding. It may also lead to the increased friability as well. And then a development of wear ring in the die cavity. Sometimes a wear ring is generated in the die cavity due to continuous compression. So we can invert this die, because the compression normally takes place in upper 2/3 part of the die cavity. Lower 1/3 part is always holding the lower punch. And that's why if we invert the die, normally we can solve this problem. But nowadays, no industry is going for that. And next is the incorrect setup at the press. If during ejection, the lower punch is not actually traveling to the surface of the die table. Ideally, in a die table, સુધી આવવું જોઈએ. પણ ઘણી વખતે શું થાય, the lower punch is not traveling to the die cavity. If it is remaining somewhat lower, then the tablet will remain in the die cavity. And during ejection, it may break. So it may separate in the layers. That is capping or lamination. So we need to set the punches properly. Next problem is picking and sticking. As it is shown over here, the material from the upper surface of the tablet is picked by the punches. When the tablets are compressed, the mass which is picked, taken away by the punches, it is called picking, which is sticking to upper punch. And the mass which sticks to the die cavity, it is called sticking. The reasons for that may be the embossing or engraving. If you are using embossed punches, then the fonts which you are using should not have any closed surfaces. As it is shown in the first image, they are closed surfaces, and that's why they are picking the mass. Here, they are open surfaces, or the angles are adjusted in such a manner that they will not pick the mass. So, when we are using embossing or engraving, we need to take care of that. Next is improper lubrication. If the lubrication is not proper, then we need to lubricate it properly. Then higher moisture content. If the moisture is higher, then the granules will stick, obviously, because they are wet. So we need to dry the granules properly. Sticky material which are present in the formulation. We can use adsorbents or anti-adherents. We already discussed that MCC can be used as an anti-adherent. As an adsorbent. It will absorb the sticky material, and it will prevent the picking and sticking. And then rough punch surface. If the punches are used repetitively, then there are chances that the punches are becoming rough. And as we know, that rough surface will pick more mass than the smooth surface. So we can go for chromium coating of the punches because it makes the punches smooth. And low melting components in the granules. Some API like ibuprofen, which are having low melting point. Some ingredients like PEG, if they are incorporated in the tablets, they are having low melting point. So if you are operating machine at a very high speed, the material will melt and it will make the mass sticky. So we can reduce the speed, or we can use any cooling mechanism so that the melting will not take place. Next is mottling. Mottling is uneven distribution of the dyes and colors. When the dyes or colors are not uniformly distributed on the tablet surface, it will show mottling, as it is shown over here. The reason for the mottling is colored API. If your API itself is colored, and as we know that the content of the API is normally very less, so it will not impart the color to the entire tablet. So we need to incorporate coloring agent so that we can color the entire tablet. And second is the migration of dye. We have discussed while discussing granules. Normally, when we are drying the granules, the solvent will migrate, and along with the solvent, the dyes which are water soluble, they will also migrate. Okay, the water soluble dyes will also migrate, and they will make the surface solvent rich with the dye. Now, when these granules are compressed, then this less colored surface from within will get exposed. It is like chatpati, chana. When you press the chana, the cover breaks and the inner core is exposed to the surface. Okay, the same may happen with the granules when the granule is compressed, and hence the color will be uneven. There are some dark patches, some light patches, and it is called mottling. So in such cases, we need to change the solvent, or we need to reduce the drying temperature so that drying takes place slowly and solvent migration is avoided. And that can avoid the mottling. Next is weight variation. Weight variation is the difference in the weight of the tablets within a batch. As per pharmacopoeia, the limits are provided for the weight variation. If your average tablet weight is less than 80%, the allowed limit is 10%. If weight is between 80 to 250, allowed limit is 7.5%, and more than 250, the limit allowed is 5%. So there should not be more than that variation in the tablets. It may be due to the broad granule size, or poor flow, or poor mixing, or punch variation. If the granule size is very broad, we need to reduce the granule size to a narrow range. So we need to use a proper size granules. If flow is improper, we need to incorporate gradients to improve the flow. If mixing is not proper, we need to mix the mass properly. And if the punches are not uniform, we need to make the punches of uniform size so that each time dye is filled properly. Next is the friability. Friability is the breaking of the tablets from the edges, from the surface. It may be due to over drying. If the drying is over, binding will not be proper. If binder is less, then also binding will not be proper. We need to incorporate more binder. If lower compression pressure is there, then also the tablet crushing strength will not be proper. and over lubrication. When the granules are over lubricated, then the surface of the granules is coated with the lubricant and not the binder. Okay, over the binder layer, there is a lubricant layer. And when we compress it, two lubricant layers are coming in contact with each other. Now, they are not having the binding properties. Their function is to prevent the binding. And that's why the binding will not be proper, pressing strength will not be proper. And hence, the tablets may show higher friability. Next is double impression. When you're using rounded punches, then the punches are always rotating, always moving. So between the pre-compression and actual compression, when your punch rotates, then it leads to double impression, as it is shown over here or on here. Okay, in this bisect, you saw in bisect, you can observe the double impression. In 402 units, you see, you observe the double impression. That is due to pre-compression and compression. So what we need to use, we can use the locks in the punches. If we use locks in the punches will not rotate and we can avoid the double impression. With this, I'm ending my lecture. If you have any question, you can ask.